All right, so I'm back again for the next part of the sequences packet. All right, we're actually going to turn to the end of the packet now. If you could turn to page 13, and we're going to take a look at something called geometric series. All right, so this right here, this is the formula we use for a geometric series. And a geometric series, I mean, really all you're doing is you're finding the sum of a certain number of terms. All right, so I mean, everything in this formula you've seen before, right? So this is pretty self-explanatory. This is the only new symbol. This just means the sum of the first n terms. So, I mean, honestly, I think you guys could probably, if you hit pause right now, you could probably just try out number 26 on your own and see how you do. So try it out. Okay, so at this point, if you tried it out, let's just read it. It says Alexa earns $33,000 in her first year of teaching and earns a 4% increase in each successive year. So the first thing they want us to do is they want us to write a geometric series. They're telling us to call it S sub n for Alexa's total earnings over n years. So all that they really want us to do is just plug the numbers into this formula above. Now A sub 1 would represent what she's making in her first year. So we'll replace that with 33,000. And then again, we can replace the other A sub 1 with that. Now the R, well, if she's earning a 4% increase, that would be 1.04, right? Because it's one whole of her salary plus the 4% increase that she's earning. Then we're going to raise that to the n power, and that's just going to be over 1 minus R, so 1 minus 1.04. And you can leave it like that, right? I mean, the only thing you really could do to this formula if you wanted is you could combine this to make it say negative 0.04 on the bottom, but you can just leave it right like this, okay? So again, A sub 1 is 33,000. R is the rate at which her salary is increasing, so it's increasing by 100% of what she made plus 4% added onto that, which is 1.04. We're going to bring down the n. We want to leave it in terms of n. And there we go. All right, now Part B wanted us to use this formula to determine her earnings for her first 15 years of teaching. So all we're going to do is just replace the n with 15. So let me just plug this in. I mean, there's not really much to do here other than to just plug it in your calculator and see what it's equal to. All right, so again, all we really did was we just replaced this n with 15. Okay, that was the number of years we were talking about. And when you plug that into your calculator to the nearest cent, you're going to wind up getting $660,778, and to the nearest cent, 39 cents. So this is the sum of what you would make in our first 15 years of teaching. All right, so let's take a look at number 27. It says, Jasmine decides to put $100 in a savings account each month. The account pays 3% annual interest, compounded monthly. How much money, S, will Jasmine have after 1 year? Okay, so again, I would actually hit pause, and I would take a look at these answer choices, take a look at what you're given, and see what you could figure out, and then once you come up with an answer, just hit play and see how you did. Okay, so the question says, how much money will Jasmine have after 1 year? So, I mean, we're really using our sum of a geometric series formula, and answer choice 1 and answer choice 3 don't follow those formulas, okay? If we want to know, how much she will have after 1 year, that's the sum of those 12 months. Okay, so we're really deciding between answer choice 2 and 4. Now, the reason why it's not going to be answer choice 4 is because it says that the account pays 3% annual interest. And, this number right here should represent the monthly interest since we're raising it to the 12th power. Okay, we want the sum of the first 12 months. So this right here can't be our answer. Now, just to verify why it is choice 2, if they say that it's compounded monthly, well, we know that our compound interest formula looks like this, right? Within the parentheses, it's 1 plus the rate divided by n, and that's being raised to the n times t power. So if we want to take the information they gave us, if you want to put in 100 for the p, you can, but it's 1 plus the annual interest rate is 0.03%, but because we want to find, because it's compounded monthly right here, we're going to need to divide that by n, by the number of times a year that it's accumulating interest. And we're also going to have to replace this n with a 12, and I'll just leave that to the t power for right now. Okay, so if you plug this in your calculator, that's going to give you 1.0025, and I'll bring down my 12t power. So anyway, this right here, this is our monthly interest rate. So for the R in the formula, this is the number that you're going to want to replace it with. Okay, so choice 2 is our answer. Okay, so let's look at, take a look at number 28. And again, I would try it on your own first and then hit play and see how you did. Okay, a ball is dropped from a height of 32 feet. It bounces and rebounds 80% of the height from which it was falling. What is the total downward distance? I'm going to underline that. In feet, the ball traveled up to the 12th bounce. Okay, you know, I'm just going to say this question doesn't say what to round to, and in the end we are going to have to round, so I'm just going to say let's round to the nearest foot. Okay, so we're trying to figure out the total distance that the ball traveled up to in the 12th bounce. Okay, so let's see. We're going to use our formula, and we're looking for S sub 12, right? The total distance the ball traveled up to in the 12th bounce. Okay, so let's replace the A sub 1 with the initial height. So A sub 1 minus A sub 1. The R we can replace with 0.8 because it rebounds 80%. It maintains 80% of its height from the previous bounce. So we're going to replace that with 0.8 or 0.80. And the N is going to be 12. Okay, so then in the denominator it will just be 1 minus R, so 1 minus 0.8. So you can just plug that in your calculator and see what you get. You get to the nearest foot, this is going to be equal to 149 feet. Okay, so if you just turn to the next page in your packet, page 14, we're going to talk about the last topic in this packet. And this is called, you could call it either summation notation or sigma notation. All right, this symbol right here, I mean, some of you may recognize this. This right here is the sigma symbol. It's just one of the Greek letters in the, it's just one of the letters in the Greek alphabet, okay? So it means sigma. And we also call it summation notation because it tells us to take the sum of some terms here. Now, let me just explain in a little bit more detail what this means. The number on the bottom, see how it says k equals 3? This is going to be our starting value, which I'll explain in a minute. And on top, we have a 6. This is going to be our ending value. What we're going to do is we're going to start with 3, k equals 3, and we're going to replace the k in this expression with a 3. So let me just do it as I talk about it. So this is going to be equal to 2 times 3 plus 1. Okay, now we're going to add to that what we get when we place the next consecutive integer after 3 in for k. So the next consecutive integer after 3 would be 4. So now we're going to add to that 2 times 4 plus 1. Okay, so 2 times 4 plus 1. Okay, now we're going to plug in the next consecutive integer. So we're going to do 2 times 5 for 1. We're going to keep replacing the k with the next higher consecutive integer and the next higher one after that until we reach our ending number, which is the number on top of the sigma symbol. That's going to tell us where we're going to stop. So once we do 2 times 6 plus 1, that's where we're going to stop. Okay, so let's figure out what this is equal to. So 2 times 3 is 6, and 6 plus 1 is 7. Okay, then I'll bring down my addition sign. So 2 times 4 is 8, plus 1 would be 9. So we're going to add 9 to that. And then plus 2 times 5 is 10, plus 1 is 11. And then finally, 2 times 6 is 12, plus 1 is 13. So if we add all these together, 7 plus 9 plus 11 plus 13, we're going to wind up getting 40. So the sum of 2k plus 1 from k equals 3 up until k equals 6 is 40. Okay, so if you take a look at number 30, I mean, it's pretty much the same thing. The only difference is there's a 10 plus in front of that. So all that's saying is take the sum from n equals 1 up until 5 of n cubed minus 1 and just add that to 10. Okay, so why don't you hit pause, try it on yourself, try it by yourself, and then hit play and see how you did. All right, so let me just I'm going to bring down the 10 plus. I'm just going to open up a big bracket to separate them, although you don't have to. Okay, so then we have n cubed minus 1. So it's telling us, let's take this, n equals 1. Let's take this 1 and replace it for the n. So that's going to give us 1 cubed minus 1. Okay, then we're going to add to that. Now we want to replace the n with a 2. So 2 cubed minus 1. Then we're going to add to that the next consecutive integer being cubed minus 1. And then plus 4 cubed minus 1. And once we get to this next one, 5 cubed minus 1, we know we're going to stop because 5, okay, this number right here, this 5, is what's on top of our sigma symbol. All right, so just figure out what this is all equal to. All right, so 10 plus, I mean, you could drop these brackets. You don't need them. That's, up to you. But 1 cubed minus 1 is just 0. Okay, bring down the addition sign. 2 cubed minus 1 is 7. 3 cubed minus 1 would be 26. 4 cubed minus 1 would be 63. And then 5 cubed minus 1 would be 124. Okay, and then when you just add all this together, you wind up getting 230. Okay, so try out number 31 and 32 on your own and see how you do, and then check your answers with me. All right, so a ball is bounced from a height of 8 feet and is allowed to bounce. Each time the ball bounces, it bounces back to half its previous height. The vertical distance the ball travels, d, is given by this formula, where n is the number of bounces. Based on this formula, what is the total vertical distance the ball has traveled after 4 bounces? Okay, so let me write this out. We have d equals 8 plus 16 times the sum from k equals 1 up until n. Now, they tell us n represents the number of bounces, right? N is the number of bounces. And they want us to figure out how far the ball has traveled after 4 bounces. So I'm going to replace that n with a 4. And that's going to be 1/2 to the k power. Okay, so let's do this. So d equals 8 plus 16 times, I'll just put a big bracket there, the sum from k equals 1 to 4 of 1/2 to the k power. So let's see, we're first going to take 1/2 and we're going to replace that k with 1. Okay, remember, this tells us where to start and this tells us where to end. All right, so then we're going to do plus 1/2 to the second plus 1/2 to the third. Oop, that should be a 2. And then plus 1/2 to the fourth, and that's going to tell us where to stop. We know we're going to stop there because this 4 is the number on top of our sigma symbol. Okay, so let's figure out what we have. So we have d equals 8 plus 16 times 1/2 to the first, is just 1/2. 1/2 squared. When you square a fraction, you just square the top and square the bottom. So 1 squared is 1 and 2 squared is 4. Okay, now we're going to cube the top and cube the bottom. So 1 cubed is 1 and 2 cubed is 8. And now let's raise the numerator and denominator both to the 4th power. So 1 to the 4th is 1 and 2 to the 4th is 16. All right, so we'll have d equals 8 plus 16 times, all right, well, I mean, I'm just going to kind of do this quickly. If you want to add these fractions, you would find a common denominator, which the common denominator would be 16. So if you add all these up, I mean, technically you can use your calculator, but I prefer for you not to do that. To get this first fraction to have a denominator of 16, we'll multiply by 8 over 8. The second fraction, we would have to multiply by 4 over 4. The third fraction by 2 over 2. And the last fraction already has a denominator of 16. So basically all of these denominators, right, 2 times 8, 4 times 4, 8 times 2, and 16, they all say 16. So we're going to keep our common denominator of 16. And then when you add the numerators, 8 plus 4 plus 2 plus 1 would be 15. So we're going to have 15 over 16. Okay, so we have D equals 8 plus, all right, so if you multiply these, right, 16 over 1 times 15 over 16, I mean, this 16 on top cancels with the 16 on bottom and leaves you with just 15. So here, D is going to be equal to 8 plus 15, which is 23. And remember, always label your units, so feet. All right, and finally, the last question in the packet. So Kristen wants to increase her running endurance. According to experts, a gradual mileage increase of 10% per week can reduce the risk of injury. If Kristen runs 8 miles in week 1, which expression can help her find the total number of miles she will have run over the course of her 6-week training program? Okay, so I'm going to just start by kind of organizing myself over here. All right, so let me just do this. In week 1, week 1, she wants to run a total of 8 miles. Okay, in week 2, she'll want to increase that by 10%. So if you take 8 miles and you want to increase it by 10%, you want to multiply it by 1.10%. So 1.10 or just 1.1. So in the second week, she's going to want to run 8.8 miles. Okay, now if we go to week 3, she's going to want to increase that 8.8 miles by 10%. So you're going to do 8.8 times 1.10. And that gives you about 9, well, not about, it gives you 9.68. Okay, and that's going to keep going. So I'm just going to stop here. Okay, so this is her goal. And again, ... that would just kind of keep going. All right, now, if you look at these formulas here, I mean, this we can use, right? This means summation from week 1 to week 6. And then this right here, this is our sum formula as well. It's our geometric series formula. So I'm going to start off with these two formulas on the bottom here, okay? We know that the sum formula, it looks like this. S sub n equals a sub 1 minus a sub 1 times r to the n power, and that's over 1 minus r. Okay, so if we were to plug in the numbers here, right? A sub 1, the first week, she'd be running 8 miles. So I'm going to replace those a sub 1s with 8s. And then since she's increasing by 10%, this would be 1.10 to the, this is going to be over 6 weeks. So this is going to be to the 6th. And then over 1 minus the rate, which is 1.10. Okay. So basically, you could either leave it like that, or you could write 8 minus 8 times 1.10 to the 6th power over, and then 1 minus 1.10 would just be negative 0.10. Now let's look at these answer choices here. This one doesn't match up because the denominator is not the same. And this one, first of all, they used an n as an exponent, which, okay, they should really be using a 6 because we want it after 6 weeks. But also, in here, they used just 0.10, and down there, they have the wrong denominator as well. So neither one of these two really work. If they wanted to use that formula, it would have to look like, you know, like this right here. Okay, so let's decide between choice 1 and choice 2. Now, they both start at week 1, right, and end at week 6, and they both have the initial times 1.10, so the only difference is their exponents here. Now, we know that the way the geometric explicit formula works is you're taking a sub 1, and you're multiplying it by r, and you're raising it to the n minus 1 power. So, I mean, choice 1 follows the formula, so I'm assuming choice 1 is going to be our answer here. But you know what's a good idea just to double check? I would plug in a 1 for n, and then a 2 for n, and then a 3 for n, and see if you get these same output values. So if we were to take, let's say 1, and replace it for the n, we would have 8 times 1.10 to the 1 minus 1 power, which is really just to the 0 power, And if you do that, I mean, anything to the 0 power is just 1, so 8 times 1 is 8. So far you could see, look, when you plug in a 1 into this expression, we wind up with 8, which is what we get for week 1. If we were to, let's say, I'm going to just kind of do a little bit of, well, I'll just bring it down here. If we were to do the second week, right, we would do 8 times 1.10. So now we're replacing this n right here with a 2. So 2 minus 1 is 1. Now, if you look here, I mean, 8 times 1.10, isn't that what this says right here? So it has to be equal to 8.8. If you continue on with this trend, right, we're going to add on there 8 plus 1.10. Now we're doing for the third week. So 3 minus 1 is 2. You will see that you will get the 9.68, and this is supposed to be a 2. And you'll see that these numbers follow in line with these numbers. So choice 1 is our answer.